All right. All right, hey everyone. So nobody asked on Piazza about the ESC180 grades. That is what it looks like. So the average was, I know, I think 68 or something like that. So about the usual. The way the grades were computed is just as per the syllabus. So I announced that the online exercises were half a point each, but on the syllabus they were worth 2 points in all. So everyone got 1% free. Otherwise, that's the grade. So you can submit regrade requests on Gradescope. So the regrade requests that you submit go to the TAs. I think some people have heard back from the TAs now. There's a few people still waiting from the TAs. Like if you submit it within a month, that's fine. So on eMarks, I'll review whatever the TAs fixed, and then within a few days, the grades on eMarks are going to be updated as well. All right. So that is that. And one more thing. So because the thing goes to the TAs, you get an answer from the TA on Gradescope if you complain about your grade. And sometimes they agree, sometimes they disagree. If you want to, you get another chance to email me. Like if you think you have a reasonable argument and you still disagree with the TA, you can email me. I usually side with the TAs because I know the TAs, I don't know you. But, like if the TA is wrong, I want to fix it as well. So you can email me as well. All right. So that's that. I apologize. I know I told you to email me. I am behind on email. I've been having some health issues. I will really try to get back to everyone as soon as possible. If you have anything urgent, please just email me. I do check email. I just have a bunch of unread things. So I'll try to get back to everyone as soon as possible. Anything urgent, just email me again. Sorry about that. I'll try to get on top of things. Okay. So what I want to do today is do a bit more about how the C is project 3 graded? Not yes, project 3 is definitely graded. I know it. Yeah. So ungraded on Gradescope doesn't mean anything. So whatever is the auto-graded score on Gradescope, that's your grade, with very few exceptions where if it was very low and we reviewed it, we sometimes fix it up manually, but that's like literally a few people. So ungraded on Gradescope is just like a bug on Gradescope. So okay. Okay. Is there? You were a TA for CS in grade 12. That's cool. Okay. All right. So Okay, so what we're going to do today is basically review almost everything that you need for project one. So once we have the material for project one, which will be, I believe, probably on Wednesday or Thursday, we'll post project one. And I'll briefly review typedef and structs, and then we'll see how structs interact with pointers. Okay. So just very briefly, typedef is basically renaming types. So you can say that you want to have a custom type that you, for example, name as array size t. But actually, anytime you say array size t, it just means int to c. So here you're defining this variable size of array, which is of this type, which is really of type int. So that seems kind of not useful. This might seem a little bit useful if you have kind of like longer type names, like unsigned long int. You might want to have a shorter name. In fact, there is a shorter name in C for that. Yeah. It just substitutes it in, essentially. Yeah. Yeah.
You still use int though, like
oh yeah. Yeah. You can still use int. It's just that you're saying, well, I want the special type like array size t, so t for type. Okay. So one way in which it's useful is if you want to, use something else for everything that's an array size, you can just substitute in the ones. So you can substitute int for something like unsigned long int over here. You just do it the once in the code. That might be useful if you're switching to a different computer architecture where you want a larger potential array size, for example. Yeah.
So in that scenario, you do typedef unsigned long int and then int.
That's right. Yeah. So you would just change your code where you say, well, like now it's going to be typedef, unsigned long int. Yeah. All right. So that was from last time. This is just review. Why do we use size t? So again, kind of one reason would be that you want to change what this kind of thing actually means. So okay. So one common use of typedef is with structs. So for example, if you want to have a custom data type, which is a compound data type, so it has several different things in it, you might do it like this. So you would say, okay, so your type is struct student, and this student as a type contains actually several different, it's called fields. So it has, 200 characters of name, 11 characters of number. If you remember 11, because if it's like 10 digits plus a null, if you want to print it with printf, for example, and you have a GPA. So you can use it like this. So you can say, I want a variable that's of type struct student. So this is struct student. The name of the variable is going to be S1. And you can, for example, print it like this. So if you want to access a field of a struct variable, you can use it using you can do that using the dot. So you can say s1.name, and what that will get you is this string. All right. So this is, by the way, I'm talking fast because this is review from last time, but stop me if you have questions. Okay, with me so far? Okay. So you can combine it with typedef. So you can essentially say typedef, and then this whole thing, you're saying, instead of saying this whole thing, I'll say student. So that is kind of how you would read it. And now, instead of saying struct student, like we had to say over here, you can say student s1 is equal to whatever. So that means that the variable s1 is of type student. Yes.
So whenever you declared a struct, do you have to say typedef struct student
And then also again at the end, do they have to be the same thing?
No, so they do not have to be the same thing, although that's a common pattern. So here we said just struct student, and then we just name it struct student. Here, what I'm saying is I'm saying typedef all of that, and then I happen to have named it student. It could be anything else. It could be like ST or something. Make sense? But that's kind of the common pattern. It's like, why would you name it anything other than student if it's struct student, right? Is that okay? Yeah. Struct is not a function. Struct is a keyword. So the way we, so kind of what is struct? Well, it's like, this is how you define a compound data type. You say struct, the name of the type, and then you say what kind of things are in the struct. And then if you define a variable that's of that type, you say, if you didn't use a typedef, you would just say struct student. So this is this. Or you can do a typedef. Typedef means you're saying typedef, all of that, and you're saying all of that, I'm renaming student. And then you can just say student as well. Yeah. Right. So so kind of this is about the interpretation, right? So like what does it mean? What does it mean to have a struct student? I'm just saying I'm going to have up to 200, really up to 199 characters the name, and I'm going to have an array of size 11 for the student number. And the reason it's of size 11 is I want to have 10 digits. And then I want to have a null because I want to be able to print the student number using printf %s.
Okay, so we're creating the student number.
Right.
Student number is a string.
Right. Yeah. So I'm doing the student number as a string. Why in a sec. Yeah. So why am I actually? Because I have a question first. So why am I doing the student number as a string? Anyone? Like, why not an integer? Yeah.
You'd never want to like add or subtract something to a student number.
That's one reason. It's not really a number that I can add or well, sometimes you might, like if you are assigning student numbers sequentially, actually adding one might be useful. Any other reason? Yeah.
Array of characters is a string.
Yeah.
So
Yeah, but I'm asking why not use it? Why not use an int? Yeah. That's one good reason, although there's ways around it. So the answer here was like, what if it starts with a couple zeros and I print it using %d? It's true, by default, it wouldn't print the leading zeros. You can make it print the leading zeros. Yes.
the ASCII stuff when you
No, that one's fine. Yeah.
Security reasons.
Security reasons. What's the security reason?
That's easy to, I don't know, hack.
Equally easy to hack. Yes. Yeah. Well, if it's an integer, I also know kind of what the number is. Yeah, over there. Say again? Well, I would put the null at the end, but that's more of a downside than an upside, right? Yeah, you have an idea?
Wait, never mind. I think I was going to say that maybe it's not less memory, but
Close. Yes. Yes, exactly. Yeah. So integers are not necessarily able to store 10 digits. So you want to make sure that you can actually do 10 digits because integers can only be so large in C. Okay. So similarly to floats in Python. You had a question before.
to implement something on this side.
All right, so scanf is, so the question was about scanf. We'll get to that. So scanf we haven't done yet, right? So if you want to, for example, scanf the name, what you would do is you would just say, s1.name. So in the same way that you can do printf with s1.name, you could also do scanf with s1.name.
Same size.
Yeah, well, so I think I don't really want to get into scanf right now, but yes, like there are issues with scanf where you need to know what's kind of you need to basically pre-decide the upper limit on the length of the input. Yeah. Okay. All right. So all right. So that's that. So pointers to structs. So in the same way that you can have a pointer to an integer, you can have a pointer to struct. So here we have student s1 and we have address s1. So that's the address where the data is stored. This address is stored in PS1. And then in order to get to the name, you just do, well, star PS1, that's the actual S1, and then .name. So the way to think about it is star PS1 is really just S1 again, right? Because PS1 is the address of S1. And you're saying star PS1, that's just going back to S1. Let's do that in Python Tutor. Oh, I need to fix the... Okay. So we have so right now, why is it those skulls? Well, because we haven't really defined S1 yet, right? So it's whatever. So once we have defined S1, what happens is S1 contains, you know, the 200 character arrays that starts with John Doe, and then there is a null, and then after that, whatever, it does usually, it would fill out with nulls up until character 199, but whatever. And then the student number filled out like this. So this was just us initializing S1. Why is it not letting me? Hold on. All right, we'll do without that. Okay. So now it just prints, you know, John Doe 3.3. So we are now about to define PS1. So here, really, sorry, so it's not. Sorry, I'll try again so that I'll have a number to go with PS1. Okay. Yeah. It's like advertising different banks to me. So as long as it's not the Trump coin, I guess it's fine. Okay, it's not going to explicitly tell me what PS1 is, but it is going to show that PS1 is pointing to S1. And what I'm doing now is I'm just saying, well, what's star PS1? Well, star PS1 is, again, just back to S1. So star PS1.name is just going to be, you know, name, which is going to get printed. Make sense? So, all right. Questions about this? Yeah.
you copy the address of that one.
Okay, that's an interesting question. So I never actually did what you're saying. So I think what you're asking is, yeah, I really do want to. I'm not sure why it's not so let me try again to switch to a different view here. Just one sec. Yeah, that's a good question. So I want to try to answer it. Okay, now it's CIBC. Okay. All right. It's not gonna. Okay, now I think it's now gonna. Yeah. So here, what you were asking is like PS1 is pointer to student. Let me print it. So I'll try to see. I think this is what you're saying. So if I print the pointer to. I'll do it like this, and here I'll say address of S1. And here I'll say address of S1 dot name. And I'll do address of S1 dot name. And here I'll do address of S1 dot GPA, which I think is what you're asking. All right. So here's what's going on. So address of S1 is whatever, this much. And then address of S1 dot name. So you see the structure here is name, number, GPA. And it's true that in the memory table, address of S1 dot name is going to be the same. Right? And that's just because in the memory table, the way the student is stored is first the name, then the number, then the GPA. And then the address of the GPA is going to be somewhere around there, but not quite, so almost there. So I think what you're asking is if I rearrange it, would it be different? And the answer is it might or might not be different. C actually, so if it says here name, number, GPA, that means that C has decided to first put name, then number, then GPA, but that's not always going to be the case. It sometimes would rearrange it regardless of the order in which you listed them here, which doesn't matter because the way we access the name and the GPA is just using .name.gpa. We don't care about the order in which they're there. Was that your question? Yeah, okay. All right, other questions? All right. Questions about this in general? Are we good? All right. There's questions here. So what is meant by the size of arrays or strings? So the size of the array is how many elements you can put in it. So in C, you must say ahead of time what is the size of the array. You cannot put more elements in that array. A string is just a block of memory with characters in it. So similarly, you need to pre-decide on the size, although there is ways to change your mind after. Yeah.
In the code Python tutor that we just did.
Yeah.
For print F, when we were working with the structure there, we did percent F. What is percent F? Percent F like
percent F is float. Yeah. Or I mean, it stands for float. Yeah. So this is like printing this.
that was double.
Yes. Okay. So yeah, so there was also a question, why is there a student semicolon here? So this is the usual, so this is just how you declare those things. So if you're it has to be like that. So it's like always typedef and then whatever is the old type and then whatever is the new type name. And then semicolon, that's the same as in the slides. That's just how it works. So here you can just take it as given that if you want to name things students, you have to do it like that. Or you can think about it like this, where it's typedef and then this thing, and then the name of the type is student, and then there has to be a semicolon because typedef requires that. All right. So, okay. So that's like this. The arrow, and yeah, so we are a little bit behind the arrow, but anyway, so the arrow is just shorthand for star A dot B. So A arrow B is the shorthand for star A dot B. So if A is an address of a struct, then in order to get the field of A, you can do star A to get the actual struct and then dot B, or you can do shorthand, which is A arrow B, right? So in general, if what you have is a pointer to a struct, like for example, PS1, then in order to access the fields in the pointer, you would do PS1 arrow name. This is as opposed to S1 dot name. Does that make sense? Right. All right. So this we have done. And now I want to do some examples with str, and we'll review that as well on Wednesday, but I want to move on a little bit. So I want to go to strlength. So here's how you might store a string, right? So for example, at address 1032, you'll have H, and then in the following address, you'll have I, and then in the following address, you'll have null. That doesn't really matter what you have after because a string ends with a null. So you've done it in the lab, of course, but I want to do it kind of officially here. So I'll name it mystrlen. So ABC. Yeah. All right. So how can we do it? So the easiest thing to do is to just go through and we'll do it another way as well in a second. But the easy way to do it is to go through the elements of S until you get to a null, right? So I'll say int current index initially is 0. And then I'll go while S at current index. In C, it has to be in parentheses. Is not null. There is like shorter ways of doing it, but I'll do it like this. So plus plus in C, I think it was in the lab, but that's the same as. All right. So what I'm doing is I'm just like advancing current I like this. So let's just trace it. Okay, so S is like this. So oh, I didn't call it actually. So here I'm saying %d a new line. If I don't do a new line in VS Code, it's going to be ugly because you run it and then there is no new line. There is like a prompt that's after the output. So I usually try to do new lines and then I'll print my str length. All right. So, okay, so we are over here. And now we need to call mystrlen s. Gonna let me do it. Okay, now it's letting me do it. So first of all, what's going on? So here S is like this. So the A is at this address. And S here is just the address of the A, right? Because that's how strings work, is what you're doing when you're saying S is you're sending the address of the first element. So S over here is just the address of the first element. So this is the same as this. And it's the same as this S over here as well. Right? So, okay, so now we just keep checking, is S at current I equal to null? And if S has become null, then we are done. And we're returning current I. So here it worked out for me the first time. Always a good idea to check, of course, whether you need to return like current I or current I plus 1 or whatever. Here it works out because I started with 0. And if current I is null, which means that it's the empty string, right? If S at current I is null, which means that it's the empty string right away, I need to return 0 because the empty string is of length 0, right? So it works for 0. You can check that it works for 1. So there is no off by 1 error. The reason is you start with 0, not with 1. Make sense? Yeah. Yeah, so you can if you want. The question was, can you use a for loop here? The answer is this is kind of a while loop kind of thing more, I think, kind of in terms of what's idiomatic. But yes, like you can convert it to a for loop, not empty, right? But you can say int current I. People don't do this. So yes, that would work. That's the same. But people don't do this. In fact, like if you want to be like fancy, you can also do this. That also works because not equal to null is the same as just true, stuff like that. But not getting into it right now. Okay, so that was just an aside in answer to a question. But like to be clear, like why does it work? Well, because what a for loop is this is the initial condition. So this is this. And then this is the stopping condition. So this is this. And then this is whatever it is that you want to do every time. It doesn't have to be current I. It's just that usually that's what we do. Okay. So yes, you can do it. I think a while loop in this situation would be more readable. So I should say, so I'm not going to force you to follow any particular style. We are using what's called Kernighan and Ritchie style, which is that the braces for function definition go in a new line, but the braces for a while loop go on the same line. C doesn't care. It's just a matter of style. As long as you're consistent, it's fine. I'm going to try to keep it to this style. All right. And similarly for structs. All right. Questions about this? Yeah. I mean, I care a little bit. I think this one is better, but I don't care in terms of grading. All right. Okay. Questions about this? All right. So let's do it a different way. So let's say that I want to do it without the loop. So I want to do it recursively. So how would I do that? All right. So what's the idea here? So we need the base case. And we need the recursive step. What's the base case? Anyone? I have S. I want to, well, yes.
The size is one.
You don't know the size, right? Well, checking the size is cheating. Is another way of putting it. Yeah. Yeah, exactly. So, so the base case. So, what's the easiest situation is the string is empty, right? If the string is empty, that means that you know that the answer is 0, right? So, if S at 0 is null, and return 0. What's the recursive step? So I have this string S, and I want to know the size. Yeah. Yeah. Well, I can't go through each element, right? So I need like, in terms, I someone else. Yeah. Yeah.
For like the index, like add to it.
Well, I don't know the index, right? So all I have is the S.
So like the address plus 1.
Yeah. So okay. So what do I do with the address plus 1?
We add it to the like value you have right now.
Okay. So I don't exactly have a value right now, right? But I can do my strlen s plus 1. And what do I do with this? Plus 1, exactly. All right. So why is that? Well, remember how it works, right? So let me go back to here. So if I advance the address by 1 from, let's say, 1032, what I'll get is 1033. And I can say, okay, so what's the length of this string? And then whatever is the length of this string plus 1 is going to be the length of the original string. Is that making sense? Questions about this? Yeah. Yeah. So we want to know what is the length of the string starting in 1032? And the answer is, well, it's 1 plus the length of the string starting at 1033. Why? Because the string that starts at 1033 is 1 character shorter. And then we also need to account for the character at 1032. So that's going to be this. Make sense?
An array of say like integers, would you send them to streamline?
Yeah, so that's a great question. We'll get to it. So if you have an array of integers, there's not much that you can do. And that's because in C, arrays don't know what their size is. So there is no way in general to figure out what the size is of an array inside a function. There is like subtleties, which we'll get to either today or on Wednesday. Okay, but with arrays, that doesn't work. All right. So, okay. So what we're going to do, so we can say, okay, so if s at 0 is null, we return 0, right? Because that's the empty string. So if the first thing in the string is already a null, that's the empty string. The size is null. Otherwise, we return 1 plus that's it. So let's trace it. Okay. So we are now here. So S is the address of the A. And now we are returning 1 plus the address of the B. And one way of saying it, well, like if it works through the leap of faith, it must be that that's the situation, but we'll call it again. So that's what it's going to look like. So my str unless rec called itself. And now inside of this call, S is this address. Sorry, inside this call, S is this address. And again, it's not 0. And we're doing it again. So we called myStr unless rec with the address of the null. So with this guy. And that's going to return 0, which means that over here, we were waiting for what is the length of this string. And the answer is going to be 1 plus 0. Okay. So we'll return 1 plus 0, 1 plus 1, 1 plus 1 plus 1, and finally we'll return 3. Make sense? Right? Questions about this? All right. So I want to talk a little bit about allocating memory. So far what we've done is we sometimes had arrays, sometimes we had string literals. So there's several problems with arrays. So one, if you declare a local array, you cannot return the array as a series of number from a function because local arrays, just like local integers and everything, disappear after the function has finished running. So that's not a problem with returning integers because what you're doing if you're returning an integer is you're just copying the value of the integer you're returning to outside the function. It is a problem with arrays because if you return the address of where the array used to be, which is how you can, what happens when you say return, that doesn't help because you're returning the address that's no longer valid outside the function. Another problem in C is arrays are not resizable. So on the other hand, the function malloc can allocate space and memory. That's not going to go away. So here's how it works. You can so you need to include stdlib in order for this to work. So if you want to allocate a block of integers, so basically you want to get an address where you can store a sequence of 150 integers. You can do it like this. So here, what you're saying is you want to say, I want a block of this size. So size of int is the amount of memory that you need to store one int. Size of int times 150 is the amount of memory that you need in order to store 150 integers. Malloc returns an address where you can put your 150 integers. So malloc by itself doesn't know that it's integers, right? Because you're just giving it a number. This is how much memory I need. You're not telling it this is for integers. So here, this is called casting. We'll do it in more detail later. Here, what you're saying is this value is actually of type int star. Malloc has no way of knowing that you want an int star because all malloc gets is a number. So here I happen to write it as size of int times 150, but that's still just a number to malloc. Malloc doesn't know that it's about integers, right? So after you've done this, block int is going to be the address of the first element of this block where you can put stuff. You can then put stuff in there. So for example, you can say block int at 7 is equal to 42. That's the same as saying go 7 slots after the address block int and put 42 there. Make sense? So here's an example. Integers on modern architectures take more than 2 cells, but let's say that they take 2. There might on some. Here's how it would work. So you say malloc and you say, I want space for 2 integers. And the computer might say, okay, you can use 1032 as the beginning of that block. If you then say block int at 0 equals 5, that's going to write this 5 over here. You say block int at 1 equals 7, it would put 7 over here. You want to access block int at 1, that would be this 7. Because it's the same as block int plus 1, so the step size here is 2 because we assume that integers take up 2 cells. So block int plus 1 is going to be 1034, goes to the next element in the sequence. Yeah.
So depending on the type of pointer, it knows the step size.
That's right. Yeah. All right. A little bit more details about size of. So the cells that I've spoken about before are bytes. We'll do kind of this in more detail at some point during the course, just not now. Size of is how much space does this particular type take up. So int on modern architectures is usually going to be 4. So actually, when you download software, sometimes it says like you want, 64 bytes or 32 bytes, 64 bits or 32 bits. That kind of has to do with that, although not directly. So on some architectures, it's not 4. Some computer architectures, char in C by definition is 1. Char star on modern 64-bit architectures, that's going to be 8 bytes. And that's why when we printed the pointers, we printed it with LD rather than D. So similarly, in star is going to be 8 bytes, for example. Okay. Size of weirdly works with arrays. So that's something that to be careful about. So if you define an array and then you say size of array, that is going to give you the total number of bytes that this array takes up. So in this case, it's going to be 3 times size of int. So you can get the length of the array directly like this. You can say size of array divided by size of, for example, array at 0, right? Because, you know, the amount of space that the whole thing takes up divided by the amount of space that one element takes up, that's the size of the array. The issue in C is that when you call a function or when you use the name of the array in any context that's not about size of, it just gets converted to the address of the first element. And that is why I write it like this. So I write it as int star a rather than int a square brackets, which you can do, but it's the same. So over here, when you use a not in the context of size of, it just gets converted to the address of the 1, which means that size of a here is going to be 8. So 8 because of this, because usually on most architectures, size of int star is just 8. So it doesn't have to do with the number of elements in the array. It has to do with how much space an address of an integer takes up, which is usually 8 on most computers. Make sense? So the upshot is don't use size of if you want to know the size of the array. It is going to work in this specific context where you define the array and then you want to know the size after you've defined it, right after you've defined it, but it's not going to work if you send it to a function. So for that reason, when you needed to sort in the last lab, you actually needed to send in the size of the array to the function as well. All right. Okay, 1201. Sorry about that. I will see you in the lab. Bye. Slow clap.